Hi, and welcome to the Week 2 live session. This is for Beginning Algebra 0020. I felt like in my first week's video I went kind of fast, so I'm going to try not to go as fast. And again, what I do in these live sessions is go over the types of problems that you'll see in your quiz and your tests that come from the Blackboard database. At least we're using Blackboard right now. This week, the assignments you'll have are due by Sunday night, and they are a quiz and a test. Pretty simple. So each week you have a quiz and a test. It's just in week 4 you have a final exam instead of a test. And don't forget to use YouTube videos and my math lab as resources for help. I have an announcement in our classroom about my math lab and how to sign up for that. It's a really good resource, and that's where you can see the text pages. So you want to go to the announcements for my math lab. And each week I have an announcement that comes up, and I show you good YouTube videos to look at for the math concepts. So this week, one thing we'll be looking at is absolute value signs. So these are some problems that you'll see where we are to evaluate these. So these are absolute value signs. We have these symbols on our keyboard. We can type this symbol. So when you have a 30 or a negative 17 inside absolute value signs, the absolute value signs mean make all of this positive. What's inside, make it positive. It's just always positive. So even though the 30's positive, we evaluate this as 30. The answer is 30. And this is telling us to make negative 17 positive. And so that's 17. So here's a problem with a decimal number. And you can pause the video at any time to try these on your own and then see how you did. So this is the actual problem. Evaluate the absolute value of negative 0.5. So that'll just be 0.5. Here's another decimal number. Evaluate the absolute value of negative 1.001. That will equal positive 1.001. Now with these two problems, we have a little more going on. We have absolute value of negative 5 plus 5. So first, we have something to evaluate here, so we do that. Sort of the order of operations, which we'll cover more in a little bit here. So take the absolute value of negative 5, and that's 5. And write down the rest of the problem right under it. So then you're looking at 5 plus 5, and that's 10, so the answer is 10. This is how to write your work when there's a few steps to do. Write down the original problem, write how the problem looks when there's one thing done to it, and then show the answer. Now for this problem, we have absolute value of negative 9 minus 7. So we have to do this part first. Take the absolute value of negative 9, and that'll be a positive 9, and write down the rest of the problem so you can see what it looks like. So we have 9 minus 7, and that's 2. So that's the answer. This is how to write your work. Write down the original problem, evaluate one thing in each step until you get to the answer. So that's absolute value signs. Next, you'll have problems where you add or subtract positive or negative numbers, which is integers. So for this first problem, 5 plus a negative 11. So first of all, it's sort of bad penmanship to keep signs next to each other like this, so we're going to resolve that or evaluate that. A plus and a minus next to each other makes a minus. Negative always wins. and then write down the numbers. So we really have 5 minus 11. And the way I teach my students to do these, or to think about these, where they always get them correct, is to think about it in terms of money and go left to right. So here you have a positive 5. So imagine you have $5. You have $5. And then this is negative 11. So you spend $11. Where are you at? You're at in debt $6. So you clearly know it's 6, and you clearly know it's a debt. And if you do these by thinking of a number line or something else, some other method, as long as you're always getting them correct, stick with that method. But I've been teaching for quite a while, and students never get these wrong when they stop and remember to think of these in terms of money. The first thing to do is clean up these signs and get rid of parentheses and stuff. So in this next problem, we have negative 4 minus a minus 5, or negative 4 minus a negative 5, however you want to say it. So these two negatives here need to be resolved. Two negatives make a positive. So we have negative 4 plus a 5. So now you see a simpler problem there for your brain to see. So you're in debt $4, and then you add 5 to your account. Where are you at? A positive $1, clearly. And so that's the answer. So remember, you can always stop the video and try these other ones if you want, and then listen back and see how you did. Now we have a bunch of parentheses here we need to get rid of. This negative 2 doesn't need parentheses. Here we have a plus minus next to each other, so negative always wins. Write down the 7 and bring down the 8. We always go left to right, one thing at a time. So say you spent $2, then you spent $7 more. That means you're in debt $9. Then you have that plus 8. One thing at a time. If you want to make sure you get these correct and not go so fast, this is how to do it. And now you're in debt $9. You added 8 to your account. That means you're still in debt $1. Negative 1. So the answer is negative 1. For this next problem, we have 10 plus a negative 21 plus 3 plus negative 1. So let's get rid of these parentheses and clean up these signs and stuff. These two here, plus and negative, is where a negative always wins. 10 minus 21 plus 3. Got plus and minus next to each other again. So negative wins. And then you have the 1 there. So here we're looking at, we have $10 in our account. We spend 21. So that means we have a negative 9 in our account, or a debt of 9. And I bring down the other numbers. Just evaluate one thing at a time. Now I do, I look at negative 9 plus 3. That's going to be a negative 6. Bring down the negative 1. Now we spent $6 and we spent another $1, so we have negative 7. And that's how to do that. Now we look at multiplication. So basically you've got to remember your sign rules with multiplication. Positive times a positive equals a positive, which I'll write these down here. And negative times a negative equals a negative. It's just a matter of memorizing these. But it's very important that you do memorize these. Positive times a negative is a negative. Negative times a positive is a negative. So these dots mean multiplication. So when we multiply two positive numbers, we get a positive. When we multiply two negative numbers, we get a positive. So when the numbers are the same sign, we get positive. To explain why is actually quite complicated, and it's really beyond the scope of this course. So it's just a matter of memorizing these right now. Very important. When you have two different signs, negative wins. So here we have a positive 5 and a negative 9, and they're being multiplied by each other. When you have parentheses like that, or they're sitting next to each other, that's multiplication. So you just remember your multiplication rule tables. So that's a negative 45. So here we have a positive 3 times a positive 7. That's just a positive 21. And then times a negative 2. And then we have a positive times a negative, so the answer is going to be negative. And that'll be negative 42. So you have problems like that with multiplication. Next we have division. Divide and write the answer in simplest form. So these are what your problems will look like. So again, in Blackboard, see these signs here, these symbols: add, subtract, multiply, divide. Blow up your screen and make sure you see the correct symbol. Students are getting problems wrong because they think this is just a subtraction sign, or vice versa or something. Make sure you're seeing what that symbol really is, or you're going to get the problem incorrect. That's in the discussion and the quiz and the test. So make sure you're really looking at what that symbol is supposed to be, because Blackboard has it so small. Now we have 124 divided by negative 4. We have the same kind of thing going on with these division rules. Positive number divided by a positive number is a positive number. When the signs are the same, the positive wins. See that? When you have one of each, a negative and a positive wins. I'll stick this one here, I guess. Positive divided by a negative equals a negative. Very important to memorize these. So here we have a positive and a negative number, so you know the answer is going to be negative. I just don't know what 124 into 4 is, so I'm going to just do it real quick. 31, so the answer is negative 31. And I know this one's going to be negative, so I have to look at what 5 into 325 is. 25, 565. So negative 65 for this one. Now we have a negative 245 divided by a negative 7. That's going to be a positive number. I just need to check what 7 into 245 is. Looks like 35, so a positive 35. You can check yourself with a calculator. Just give yourself the opportunity to do these and actually use your brain to build that skill. Here's a type of problem that you'll see. Use a real number to represent the situation. Now these are sort of word problems. These are 3 different problems. The mountain is 45 meters below sea level. So we're just asked to write an integer that represents that situation. So that would just be negative 45. Since it's below sea level is considered 0, so that's the answer for that. For the second one, sales were 50 items above expected. Since it was above expected, the answer would be 50, and that's it. That's how to do these problems. The item was discovered 9 feet below ground. So you can imagine what the answer will be there. Ground is considered 0 since it's below ground, -9. So these are the types of problems that you'll see on your quiz and your test. Here's a different type of problem. Write the expression in exponent form. So we have 3 8s here being multiplied together. Exponents tell you how many times to multiply the number. So in exponent form it would be 8 to the third. And that's the answer. So you can try these others. Now here we have 5s. 5 times 5 times 5 times 5. That's 4 5s. So that's the answer for this. The exponents tell you how many times to repeat that base. Now we have 2 -2's. So we're going to keep the parentheses around to show that it's a negative number. That negative comes with the 2. And there's 2 of them. So -2 squared like that. Now here's 4 problems that we'll go over. So you can think we have -3 squared like this, and we have -3 squared like this. Which one is a 9 and which one is a positive 9? Are they both negative or are they both positive or what? I usually, 100% of the time, never get correct answers on that until I teach it. So you have to think about what an exponent basically means. The exponent tells you how many times to repeat this base number. So it's telling us to repeat -3 twice, so I'm going to do that, where we multiply them together. If I write this out, the definition of an exponent, what exactly that means, I can see that's a positive 9. -3 times -3 is a positive 9. Now with this, -3 squared, what would the difference be? So this is telling us that this is the base, the 3, and we're to repeat the 3. So this negative is like a -1 being multiplied by 2 3's like this. Once I write out that intermediate step, I can clearly see the answer is -9. So this part is very important. Students always get these wrong. And it's not a matter of memorizing which is which. Understand what exponents basically mean. There's really -1 right here being multiplied. Write out this intermediate step and you'll get it every time. You can do it. So here we have 7s with the same kind of situation. So you can try these and stop the video and see what the answers are for each one. So with this one, -7 squared, that's where we have a -1 times 7 times 7. And that's going to be a -49. With this one, this is telling us to repeat the -7's like this. And that's a positive 49. So no matter what the numbers are in here, you can do those types of problems. Now Now we're going to go over the order of operations. So I'm going to use a different color. So you might have heard of this before. So P is for parentheses. When you're given an expression to evaluate, or an equation, you look for parentheses. Anything in parentheses, you evaluate first. Next, what you evaluate, because this way you'll get the problem correct. E is for exponents. Next, anything with an exponent needs to be evaluated. Now these two, multiplication and division, come together. That's the thing that is not explained very well at all, usually in classes. M for multiplication, and D for division. From left to right though. So you're going to have to remember it's from left to right. So sometimes division might come first. Whatever comes first from left to right, you do that. And then same with addition and subtraction. They come together. Sometimes subtraction comes first. That's what I mean by they come together. Addition and subtraction. Oops, I didn't put left in here. Let me correct that. That's what happens when I talk and write at the same time. Always happens. I mess something up when I talk and write at the same time. Okay, multiplication and division from left to right. So multiplication and division does come before addition and subtraction. And then addition and subtraction from left to right. So we'll do these. We'll use the order of operations on quite a few expressions today. So here's some first examples, which you'll see in your work. Evaluate 20 times 11 plus 15 times 12. So can you see what we have to do first? A lot of times I'll underline this for myself. I have to do the multiplications first. We can do both of them at the same time in this step because they don't affect each other. But usually you want to do one thing at a time. So 20 times 11 is 220 plus sign from here, and then 15 times 12, which I don't know what that is on the top of my head. I have to hand write it out. 180. So then we're looking at 220 plus 180. And that's 400. So the answer to that expression is 400. Now for this expression, we have the absolute value of negative 4 minus 50 divided by 50 times 3 squared. So what do we do first? Remember parentheses first. We don't really have parentheses, but absolute value signs can be considered as parentheses. So we'll go ahead and evaluate just that part first. So remember, the absolute value of negative 4 is 4. So I'm going to write down all the rest of this. Just write down the rest of this. Carry it down right under it so you have least chance of error to forget anything. So now what? We have subtraction, we have division, multiplication, and exponents. So exponents is next to do, according to the order of operations. So I'm going to write down the rest of this and just evaluate that exponent. So 3 squared is 9. If I want to make sure I get these correct, this is how I do my work. Here's the original problem. Here's the next step where I show how the expression changes in each step, where I evaluate one thing at a time. Now I have subtraction, division, and multiplication. Do you know what to do first? So subtraction definitely comes last. Multiplication, division from left to right. So we do this part next. Now we're going to write down what this expression looks like. The 4 comes down, the minus sign, 50 divided by 50 is 1, and then times 9. That's what our expression looks like now. So what do we do next? The multiplication. So I have 4 minus 9, and then I have to remember to think of this in terms of money. I have $4 since that's positive, and I spent $9. So that means I'm in debt $5. So the answer is -5. And I'm sure I got it correct because I followed the order of operations. Here's some more expressions to try. And remember, you can always pause the video and try these and see how you do by listening to the explanation after. Unless this is your first time to hear this. So here we have 9 minus 5 squared divided by 4 times 7. So parentheses first, so that means do this part first right here. The 9 minus 5. So 9 minus 5 is 4, and that 4 should be squared. And I'm going to write down everything else right under it. Just evaluate one thing at a time. Next, I should do exponents. And that's the 4 squared right there. 4 squared is 16. That means 4 times 4. And I'm going to write down divided by 4 times 7. So I have division and multiplication. I'm supposed to do multiplication, division from left to right. Even though I might see this is 28, this is 28, oh boy, my brain knows this is 28. I have to slow down and follow the order of operations. So I have to do 16 divided by 4 first, and that's 4 times 7. And 4 times 7 is 28. So we can move on to the next expression. 7 times 4 minus 3 times 4 minus 9 squared. So first I must do parentheses, 4 minus 9. So I'm going to write down what the expression looks like. 7 times 4 minus 3, and 4 minus 9 is -5 squared. So next, what to do? So I've got exponents right here, so I have to do that next. So I'm going to write down the rest of the problem. And I know -5 squared is -5 times -5, which is positive 25. And that's being multiplied by this -3 here, because it's sitting next to it. So we have multiplication, subtraction, and multiplication. So multiplication needs to go first. And there's 2 of those there. So 7 times 4 is 28. Minus sign, 3 times 25 is 75. So I have 28 minus 75. So that's going to be 47, right? Yeah. Next we consider algebra. We're going to start algebra now. Algebra means the reunion of broken parts, actually. It's an Arabic word meaning the reunion of broken parts. So we work to combine like terms in that sense. We start putting letters into math because it actually does help us to do so much more in this world. And we can work with theoretical situations where we don't really know the value of something, or we want to figure out how much of things to sell in order to make a certain amount of money. And algebra is the basis for calculus, and calculus is a much more precise way to do math. And the things we have figured out to do with algebra and calculus and beyond is amazing. And we're just learning the basics here, and you guys can do it. We can fly planes, we can build complex structures. I mean, there's so much we can do that we figured out. But we're just going to look at what the heck this x thing is, for example. So say we have 2x plus 5x. So this x, the way I had to learn it, it was so odd to me in the beginning. Such a strange concept, this x. And I just had to tell myself it's an I don't know. That's what worked with me. And you kind of, sometimes in math, you got to just accept something for a while and then it'll sink in later. But there's two I don't knows here. Like, we don't know the value of x. But 2 is being multiplied by x. Say that x is a thing, like a CD. I mean, that's kind of old now, but a book. The book is $2. We don't know how many books there are, but they're each $2. Okay, so say something like that. But we don't know what this is, and it also could be some other value. It could be anything, any kind of value that it represents. But there's 2 I don't knows, and there's 5 I don't knows here as well. So what we do to combine like terms, since there's addition right here, we add the 2 and the 5. And there's that many of those I don't knows. So that's going to be 7x. So if we had 3x plus 7x is a total different type of problem. 3, I don't know what the heck those are, but we have 3 of them. And then we found 7 more of those same things. That's 10 of those things. So that's how to start working with letters in math. And you can subtract them as well. Say we have 9 I don't knows minus 6 I don't knows. So it's basically 9 minus 6 of those things. So that'd be 3x. And you can have 6x minus 9x, start to really work with positive and negative numbers, all kinds of things. You're basically looking at what's called the number in front of x, the coefficient, and adding those or subtracting them. So also we had 2x plus 5x. You could have 2a plus 5a. Any of these numbers, I mean, we have 26 letters to work with. That would be 7a, 3a plus 7x, like I had right here. Oops, and that's 3a plus 7x. A plus 7a, that'd be 10a then. So you have to stay with the letters that you're using. This 9x minus 6x could be 9b minus 6b. So make sure your letters and numbers are clear. That'd be 3b. So we have 26 letters in our alphabet that we can use, and when we run out of those, we go to the Greek alphabet usually in math. It just gives us a lot of options. And that's an introduction to using letters in math. So your problems will look like this, a little more complex, but I'll show you what we're doing. So for this first problem, we have 5x minus 2x plus 2. So you have to look for terms that are alike. These two are alike because they're both x terms. This is not an x term, it's just a number. So we cannot combine them with those. But we know 5x minus 2x is 3x. And then I bring down that 2 as well. So this expression is what we're combining like terms in, or we're evaluating, simplifying. So here's the original problem, and now here's what it looks like. So I combine the 5x and the 2x as 3x plus 2, and that's it. I can't do anything else, so that's the answer. Just combining like terms. The 2 is not like 3x because the 2 is not an x term. Now which one should I do? I think I'll do this one next. So we have 3x plus 2y plus 5 minus 9y plus 8x plus 2. It's a lot, but it gives us a lot to work with and learn. So I basically just got to look for like terms because I need to combine them. So I'm going to underline my x terms so that I can see them. And then I have y terms. So I'm going to underline my y terms so that I can see those are alike. It helps me not to make a mistake. Then I have numbers right here, and I can definitely combine those numbers. So for the x terms, I have 3x plus 8x. That's 11x. So I use those, so I'll cross those out to help my eye not to make a mistake. And then for my y terms, I have 2y minus 9y, and that's a negative 7y. So I combine those, so I'm going to cross those out to help myself. Now I have positive 5 and positive 2, so that's a plus 7. And I used those. So now I see I used everything. So this expression has become 11x minus 7y plus 7. And those are all unlike terms. This is an x term, this is a y term, and this is a number. They're all unlike, so that'll be it. And you can go in my math lab and practice these. And my math lab will tell you right away if you're correct or not. My math lab's a really great thing. Now we're going to look at this expression. 3xy minus 3x plus 4xy minus 5. So this xy, 3xy is just a term. 3xy is a term. So here's an xy term. And I've got another xy term. So those are alike. Because they have exact variables in there. Now I have a 3x term and I have a number. And those aren't alike. So there's no other like terms to underline. So I can combine the 3xy plus 4xy, and that's a 7xy. And I'll write down, definitely carry down, the leftover. So this expression has become this. And there's no like terms there, that's it. So we just circle that. That's our answer. For this one, 5xy minus 7xy minus 1. We have xy terms that are alike, then we have a number. So we can combine those xy terms. We have 5 of them minus 7 of them, so that's negative 2xy, and also the negative 1 is part of it. And that's it because we have a number and we have an xy term, and they are unlike. I hope that makes sense okay. Don't forget you can replay the video recording if you need to. And also there's a lot of instructors teaching these on YouTube. So now we're going to use the distributive property to simplify these. So you have problems that look like these. 5 times x minus 2y. And always follow the order of operations. The 5 sitting next to parentheses like this means multiplication. Remember, the distributive property means 5 times x and 5 times negative 2y. Distribute the 5 to each. Share the 5 to each. But first, we always check if there's something we can combine within parentheses, because we're supposed to do parentheses first. But this is an x term and this is a y term, so there's nothing to combine there. So we have to go ahead and do multiplication. So this will look like 5 times x, and when you multiply, we kind of jumped here, but when you multiply numbers and letters, they just stick together. 5x. Now we have 5 times negative 2y, so we're going to multiply the 5 and the negative 2, that makes a negative 10, and then the y is hanging in there. 5 times negative 2y is negative 10y. So we skip, usually we explain a little more in a math course about how to do those, but you are in an accelerated course, being 4 weeks. So you're just going to have to really practice these and pay attention. Now this is an x term, this is a y term, so they're not alike. You always combine like terms if you can, you always do. But that's it for that one. Now here we have 4 times x minus 3y. So this is an x term, this is a y term. Nothing to combine with those. So we're going to go ahead and use the distributive property with that 4. So 4 times x is 4x. And then 4 times negative 3y is where we multiply the 4 times negative 3. Numbers always get multiplied by each other. So that's a negative 12, and then a y. That's an x term, that's a y term. Can't combine those, so that's it. Now here we have 3x minus 2 times x minus 2y. So parentheses first, there's nothing to combine in there. So we've got subtraction going on. We also have multiplication right here. So we have to distribute this 2, or negative 2 really, to each term inside the parentheses. So I have to do that first. So the 3x comes down, then we're looking at negative 2 times x, which is negative 2x, and then negative 2 times negative 2y, that's a positive 4y. Now these are alike, so I combine those. So 3x minus 2x is 1x. We don't really write the 1, so just x plus 4y. And that's it. I don't know why I used the white instead of the blue. So now we have 8 times 3a plus 2 minus 5a minus 2. Okay, so there's nothing to combine in these parentheses, either one here, so we're going to look towards using the distributive property. So we need to distribute the 8 to each term here. 8 times 3a, 8 times 2, but also there's something to distribute here. You have to remember this negative, when you have a negative like this, there's a secret 1 right there that we have to distribute to each term inside the parentheses there. Subtraction signs are really tricky, especially right in front of parentheses. So let's distribute the 8. 8 times 3a is 24a. 8 times 2 is 16. Then we have negative 1 times 5a, and that's negative 5a. Then we have negative 1 times negative 2, which is positive 2. Now we're looking for like terms. So we have a terms right here that are alike, and I'll combine those. Then we have numbers right here that we can combine. So 24a minus 5a is 19a, and then 16 plus 2 is 18. So that's it. So we have a different type of problem here. We're given an expression that we have to evaluate. This is 3x plus 5, and we're given for x equals 5. We're given the value of x. So what we're going to do is plug in 5 for x. 3 is sitting next to x, so that means multiplication. However you want to write the multiplication. Plus the 5. So since I was given that x is 5, I plugged in 5 for x. And now I evaluate. Have to do multiplication first. So I have 15 plus 5. And 15 plus 5 is 20. So the answer is 20. So that's the type of problem where we're given a value for the unknown variable. We do know it, so we go ahead and plug that in. And then evaluate. Another example is this, where we have 7x minus 3y divided by x plus 10. We're given that x is 3 and y is 5. So I'm going to write my division bar, the subtraction sign there, the addition sign. I have 7 sitting next to x, so that means multiplication. So 7 times 3, since x was given as 3, minus 3 times 5, since y was given as 5. And down here I have a 10. That comes with the problem, and I have x right here. And x is 3 as we're given. So now I'm to evaluate this. So I'm going to do it across like this, because we'll evaluate this and this separately. 3 plus 10 is 13. That's pretty simple. Now we do multiplication first, right? So this would be 21 minus 15. 13's on the bottom. 21 minus 13 is 6. As long as this is a simplified fraction, then we're done. 6/13. Now here's another expression that we'll try. We are given values that we can plug in to our expression. A squared minus 6abc plus b squared. So a is given as negative 2. And a is squared. So I have to use parentheses to show that all of that negative 2 is squared. And I'm plugging things in right under that given expression, so I don't make a mistake, or at least I reduce the chance of error there. So then subtraction sign and 6. Now I've got a, b, c. That means a times b times c. So negative 2 times negative 7 times negative 3 plus b squared. So b is negative 7, so I've got to make parentheses around that to show that all of that is squared. So here's our expression with everything plugged in. We just need to use the order of operations. The order of operations says parentheses first. There's nothing within parentheses to do. This is just multiplication. And so exponents is next. So I need to evaluate these two next. So here's my given expression, and I show how it changes in each step. So negative 2 squared is 4, and I've got to write down all the rest of this mess. Negative 2 times negative 7 times negative 3 plus negative 7 squared is 49. So what I've got to do next is all that multiplication then. So you can figure that out. 6 times 2 is 12 and everything. At least we've got a negative 6. Sorry, let me check on something here. So we've got a negative 6 times a negative 2 times negative 7 times negative 3. So that will make $252, a positive $252. So we have 4 plus $252 plus 49. And then you can add those up. Four plus 252 plus 49, and that'll be 305. That's what I get. I hope that's correct, and that's what you get. And that's how to do that. Okay, here's some other expressions that you'll see now. Now we're starting a review, okay? So I think I've covered everything that you'll see this week. Now I'm going to start review with some more problems in case you want to practice. And remember, you can always pause the recorded link the video and try these yourself. But I'll go through these as well. Trying to get my writing tablet situated here. So if we have the absolute value of negative 3, remember the absolute value signs mean make all this positive that's inside. So the answer to that will be 3. Now we have a negative times an absolute value of negative 3. That's what that means there. That's really like a negative 1 times absolute value of negative 3. So what I would do is write that, negative 1 times 3, because we know this part is 3. And now I see that I have negative 1 times 3. So that's negative 3. Now for this problem, we have absolute value of some crazy decimal here. So we just make that crazy decimal positive. 0.319, that's it. Now for this problem, absolute value of negative 3 plus 3. Don't jump and see a 0, and don't jump and just write an answer, okay? Evaluate this first. Absolute value of negative 3 is 3. And then bring down the 3. Let me see if I can move this thing. There we go. And so now I'm looking at 3 plus 3 is clearly 6, and I know I get it correct. Okay, don't go too fast. You want to get hundreds on everything because you guys absolutely can get hundreds, get A's, and do very well. Now, same thing here, absolute value of negative 10 minus 5. We'll do this first. Slow down. Absolute value of negative 10 is a positive 10. Bring down that minus 5, and you're looking at 10 minus 5, which is 5. And you know you got it correct, right? That's how to do these math problems. Okay, so next we got these expressions to try. Remember, you can pause the video and try them yourself. It's up to you. And there's lots of YouTube videos with instructors teaching exactly these concepts. You just need to look for simplifying expressions or something like that. So we'll start with negative 7 plus a negative 2. Remember, any signs like this next to each other, we need to resolve or evaluate those. Plus and a minus next to each other makes a negative. So the negative 7 comes down, and just write the 2. Negative 7 minus 2. So you spent $7 and you spend $2 more. So you're in debt $9. Now for this one, negative 1 plus a negative 9 minus 5. Here's a couple signs next to each other. So we'll make this negative 1 minus 9 minus 5, and we'll do this left to right. We're in debt $1. We spend $9 more. That's negative 10. And then the minus 5. Okay? We're in debt $10 and we spend $5 more. Look, it's a fact of life. We spend money. Money is for spending. As long as we have some coming in and somewhere else. And that's a negative 15. So we did those two. Now we have 5 plus negative 3 minus negative 7 plus 10. So here's where signs are together. So I'm going to evaluate those. 5. This makes a negative 3 because you got a 1 of each, plus a negative makes a negative win. Negative and a negative makes a positive. So plus 7 plus 10. And then do this left to right. So we know 5 minus 3 is 2. So I'm just going to write the rest down, evaluate one thing at a time for myself. 2 plus 7 is 9, plus 10. I'm just going to write this over here, 19, as the answer, okay? Now, I only have a few more problems. I guess I've got a few more slides to do. So negative 2 plus negative 6 plus negative 11 plus 9. So I'm going to, the parentheses really don't matter on that negative 2. It still shows as a negative 2 without them. And plus and negative make a negative. Got the 6. Then we got plus and negative right here. So, you know, signs to the left of a number belong to that number. See that 9's right here? That's a positive 9. That negative's right there, that's a positive 2. So I'm looking at the plus and minus as going with the 11. One of each means a negative wins, so negative or minus 11, same thing, plus 9. Now going left to right, we have negative 2 minus 6. That's a negative 8 minus 11 plus 9. Okay. Negative 8 minus 11 is negative 19 plus 9. Now it's like we're in debt $19 and we added 9 to our account. Still in debt $10. Think of it in terms of money and you always get it correct. In this next video, in this next slide, we're going to practice multiplication. So our multiplication tables tell us that 4 times 8 is 32. So it's going to be a positive or negative 32. Do you know which? So positive times a negative is a negative. Definitely memorize those rules. Here our multiplication tables tell us 5 times 9 is 45. So a negative times negative is a positive, so the answer is 45. Here we have negative 2 times negative 4 times 9. Negative 2 times negative 4 makes a positive 8 times 9. I make my 9s weird, I can't help it, sorry. And so 8 times 9 is 72 there. Positive 72. Okay? Now with our exponent type problems, we have 7 times 7 times 7 right here. And what we were to do is write this as in exponent form, these two problems. So 7 is our base because that's the number being repeated. And 3 is the exponent. So that's it. They're going to ask you to write it in exponent form. So that's what that looks like, okay? Now the number that's being repeated here is a negative 6. See that? And it's repeated 4 times. So the exponent is 4. Negative 6 to the 4th power. And that's the answer for that. This is a different type of problem if you remember. Do you remember how to do that? Definitely try and do it on your own and see if you get the correct answer. Negative 4 squared versus negative 4 squared. See if you can write the intermediate steps, because once you write the intermediate steps, you can't go wrong with the answer. That intermediate step that tells you what those mean. So here we have negative 4 squared. All of negative 4 is being repeated 2 times. So when you see that, you know positive 16 is the answer. Here, this one is where you have negative 1 times 4 times 4, because only the 4 is being repeated. And once you see that, you know that's a negative 16. And it's not a matter of memorizing. If you try to memorize it, you're likely to get them mixed up. Learn these intermediate steps, and that tells you what these mean, how to break it down. Because when you go further in math, which you absolutely will be able to do, I don't know if that's in your plan, but you're going to see we build on that just a bit on this concept. Moving on, we have expressions to simplify by using the order of operations. So first we have the absolute value of negative 3 plus 25 divided by 25 times 2. So what do we do first? So parentheses first, and absolute value signs are like parentheses. So we're going to do this first. We're going to evaluate the absolute value of negative 3 first. And we're going to write down what that looks like. So the absolute value of negative 3 is 3. And then we write down all the rest. Okay, so we're showing how the expression changes in each step. Evaluate one thing at a time. Sometimes we evaluate 2 things in one step if it doesn't affect each other, but I'm definitely going to show you how to write your math work so that it decreases chance of error and you're going to be excellent in math. Because I don't know what percentage I would put on it. Maybe 70-80% of the problems that students get wrong are just because of how they write their math work. It's not in understanding the concept and using their brain. It's not a problem with their brain. It's a problem with how they write their math work. So now what do we do next? We have addition, we have division, we have multiplication. So we have to do division next. Remember multiplication and division from left to right. So I'm going to write down this 3 plus sign. 25 divided by 25 is 1. Then times that 2. So I will take a look at what I have next. 3 plus 1 times 2. So multiplication definitely comes next. So that's what I'm going to do. So I'm just going to bring down that 3. 1 times 2 is 2. So now my brain sees that's the problem, and that's the answer easily. 3 plus 2 is 5. Okay? I hope this is helping you to understand. Now we have negative 9 squared divided by 81 times 9 minus 5. Remember, if you're using Blackboard as your classroom, blow up the screen and make sure you see what those signs are. They're hard to see, these two, especially division versus subtraction. A lot of students think this is subtraction. So what do we do first? Let's see, do we have parentheses? No, but we do have exponents. So I have to do that first. Negative 9 squared is 81. So I'm going to write down everything else right under it so I don't skip or miss anything accidentally, and just see what I have. I have division, multiplication, subtraction. Looks like the division comes next. So 81 divided by 81 is 1 times 9 minus 5. Okay, so now I've got multiplication and I have subtraction. Multiplication definitely comes next. So I like to underline for myself what comes next, so when I go back I can see what I did, but after a while you don't need to do that. It's up to you, okay? 1 times 9 is 9, so I have 9 minus 5, and I know that's 4. Next, we have these problems to practice where we started algebra. So 7x minus 9x, that's like looking at 7 minus 9. We have $7, we're in debt where we spend $9, so that's a negative 2. And those are x terms, so this will be an x term. So we combine like terms, negative 2x. Now for this problem, 7x minus 9x, we're adding some stuff onto it. Negative 2y plus 6y. So these are like terms, and then these are like terms. So these made negative 2x, we already figured that out from above. And now we have negative 2 of those y's plus 6 of those y's, and that'll be a plus 4y. Okay, negative 2 plus 6. And this is an x term and that's a y term. You cannot combine those. And so that's it. We just simplify it as much as possible. Next, we have 5xy plus y minus 8xy minus y minus 1. And you can underline for yourself if you want the like terms. Remember xy like that, that's a term. 5xy here, and we have another xy term right here. And it looks like we have y terms. This is starting to look like Halloween. So positive y and then a minus y. Those are y terms, and then we have that 1 hanging out there. So let's combine the xy terms. We have 5 of those and minus 8 of those. That's negative 3 of those. Negative 3xy. And then we have a positive 1y. We don't really write the 1, it's just shorthand in math to not write that 1 there, and you shouldn't be writing it by now. I mean, if you want to, go ahead, but in your answer you shouldn't It would be writing those ones. So that's a positive 1y, and over here, that's a minus 1y, or a negative 1y. So if you have one of those and then you subtract one of those, you don't have any. So those actually cancel each other out. And then you have the negative 1 hanging out right here. Can't ignore that. And that's the answer. You have an xy term and you have a 1. Now let's take a look at this problem. 3x minus 7y minus 15x plus xy minus y plus x. So I'm going to underline some like terms. Let's start with an x term. So we do have an x term right here. Here's another x term right here. That's a 1x there. Okay, so we'll combine the ones in pink. And then it looks like we have a y term here. And we have a y term right here. And it looks like we have an xy term hanging out by itself. So if we look at the x terms, you can go ahead and combine them all at once or whatever. Just be careful. So 3x minus 15x. So we have $3 in our account. We spend $15. That's a negative 12x. Negative 12 plus that 1x is negative 11x. So we're going to cross those out because we used them. That helps us. And then negative 7y. We look at the y terms. Negative 7y minus another 1y here. That's a negative 8y. And we used those. So I combine the y terms. Now I've got this thing hanging here and it has to come down into the answer. Plus one of those xy's. And that's it. These are all unlike terms. This is an x term. This is a y term. This is an xy term. They're unlike, cannot be combined. I have 5 more slides. So now what we did was work with the distributive property. There's nothing to combine inside the parentheses here, negative 3 times x minus y. So we have to distribute that negative 3 to each term inside the parentheses. And this is how we do that. Negative 3 times x is just negative 3x. And then negative 3 times a negative y, negative times negative, that's a positive. So negative 3 times negative y is positive 3y. And so we have an x term and a y term, and that's it. When you have plus and minus in between terms, you have to really look if you can combine those. So you cannot. If they're being multiplied here, yes, you could multiply those. Okay? Multiplication with algebra and letters is different than addition and subtraction, but you will definitely get the hang of it. You'll get it. You'll get it. So now for this one, we have negative 2 times negative a minus y. So we're going to have to distribute the negative 2 to each one of these. Kind of weird looking, but we'll do it, okay? Negative times negative, we know that's going to be a positive. Negative 2a times negative a, that's 2a. Here we have negative 2 times negative y. Negative times negative, that would be a positive. So negative 2 times negative y, that's going to be a positive 2y. If you need to, take a piece of paper, if you're looking at negative 2 times negative y, for example, take a piece of paper and cover up this part so you can focus on this. Okay? And if you find other parts of the problems distracting, or other steps in math work distracting, use a piece of paper to cover it up. So anyway, we have an a term and we have a y term, and that's it. Can't combine those, so that'll be it. Now what we have, I'm going to underline something actually here. 3 times 2x plus y minus negative 1 plus x. We kind of have two parts of this problem. This huge thing and this huge thing. So we're going to use the distributive property 2 times there. And you have to remember, when there's a minus sign in front of parentheses like this, and there's a couple terms inside the parentheses. There's a secret 1 right here that we're going to have to distribute to each term inside the parentheses. And we'll do that now, next. And so what we have is 3 times 2x plus y. So 3 times 2x, that'll be 6x. And then 3 times y is 3y. Okay, so this part of the problem is done. Now we have negative 1 times negative 1, that's positive 1. And negative 1 times positive x, that's a negative x. That's how we do that. Okay, so you can think about that. Next, here's what the problem looks like. 6x plus 3y plus 1 minus x. We have to combine those x terms. So we have 6x minus x. That's 5x. And the others have no like terms to combine with it. So we just write those down in the answer. And those are all unlike terms, and that's it. So again, we have a problem here that has kind of 2 big parts to it, where we have to use the distributor property twice. And there's a secret 1 right here, where we're going to distribute the negative 1 or multiply it times each term in the parentheses. And also, if you're working with MyMathLab, what you can do is go to certain types of problems and practice them over and over. So if these types of problems are what are driving you nuts, go to those more than other types and practice the heck out of them, and then go back and practice, and then go back. You can do that with MyMathLab. You can ignore certain problems that you know you're okay at. You can practice others a lot more. MyMathLab is just a great program. And MyMathLab is not for a grade, for our class, okay? Now we're going to look at 7 times negative x, because we've got to distribute the 7 to each term here. So this is a positive 7 times a negative x, that's going to be a negative 7x. And then 7 times a 1, positive 7. And then we have negative 1 times 2 is negative 2. And then negative 1 times a negative y, which is a positive y. Okay? Now we just look for like terms. These are the only like terms. So you can put these in any order. Negative 7x plus 7 minus 2, that's a positive 5, plus y. And these are all unlike terms, so that's it. Okay, next, these were not so long. So we have 2y minus 1 for y equals negative 1. And we're to evaluate these, and we're given the value of y. So y is negative 1 because we're given that. So what I'm going to do is plug in negative 1 right where I see a y. Oops, I made a mark and I don't want it to be there. Okay. So negative 1 in for y, and 2 sitting next to y, so that's multiplication, and then minus 1. See how I did that? 2 times negative 1 minus y, because y is negative 1. So then we follow the order of operations. And that's where 2 times negative 1 goes first. So 2 times negative 1 is negative 2, minus 1. Negative 2 minus 1 is negative 3. So there's only 2 problems here on this slide, okay? So then we have negative 7y plus 2 for y equals negative 3. So I'm going to plug in negative 3 everywhere I see a y. It's only once in this problem, so then that means negative 7 times negative 3 plus 2. So I do this part first. Negative 7 times negative 3. Let me get situated here. Is a positive 21 plus 2. So 21 plus 2 is 23, which I'll stick over there. On this next slide, we have those division problems. So I really pulled the problems that you'll likely see in your assignments. So we have 5x minus 9y divided by x minus 3, and we're given that x is 2 and y is negative 1. So I'm going to plug these in right here. Put the minus signs there. I know that x is 2, so everywhere I see an x, I'm going to plug in 2. So I have 5 times 2, and then I have a 2 right here. 2 minus 3 on the bottom. I have this 9 up here, and y is negative 1. So everywhere I see a y, I'm going to plug in negative 1. Very carefully not to make a mistake or switch them or anything like that. The bottom's always kind of easier and faster to do first, so 2 minus 3 is negative 1. So I've got to do multiplication first here. So 5 times 2 is 10, minus sign. Well, I have a negative 9 really, times a negative 1. So it's a plus 9. And then that's going to be 19 divided by negative 1. And 19 divided by negative 1 is negative 19. Now for this problem, I don't have a lot of room. So let me see if I can move this part. Well, what happened? Okay. And then I'll use a different color so that maybe you can tell. We have negative x minus 3y divided by y plus 5. So I'm going to do my work over here. So I'm going to write that big division bar. I have a plus sign, the 5, minus 3, the negative sign here. So x is negative 1. We have negative x right here. So here's that negative. Okay? That negative is right there. Now x is negative 1. So I plug negative 1 in for x. Now we've got a y right here and I have a y right here. And y is negative 5. So 3 times negative 5 goes here. And then negative 5 right here for the y. So now we can evaluate. And the bottom's always easiest to evaluate. Negative 5 plus 5 is just a 0. And I already know what the answer is, which I'll explain in a second. Now we've got multiplication. This is really negative 1 times negative 1, which is a positive 1. Got negative 3 times the negative 5 plus 15. So this is 16 over 0. Now any expression that is divided by 0, you can't divide by 0, so that's called this specific word in math, undefined, at least in the English language. So the answer is undefined because we have 0 in the bottom. If 0 was in the top, it would equal 0. Can't divide 16 by 0, so that's the answer for that. Now we'll try this expression, which we've seen before. A squared plus bc minus b squared. We saw something like it. So we're given the values of a, b, and c. So a squared is first. A is -6, so -6 goes in here, -6 squared, plus BC. So B is -1 times C, which is -2. Subtraction sign, and again B is -1, so B is squared. See how I did that? That subtraction sign is right there. And then I plugged in -1 for B, and B is squared. Now I take a look at what I got to do first. There's no parentheses, this is just multiplication, so we got to do exponents first, which means to evaluate them. So -6 squared is 36, plus this stuff here, which I'll just carry down, and -1 squared is 1. And so now I have multiplication to do next. So 36. So this is -1 times -2, which is a +2, minus 1. And then we're looking at 36 plus 2, which is 38, minus 1, so the answer is 37. Now I'll do one more of those. A squared plus BC minus B squared, and you've got given values here. Don't forget you can pause and try to do this yourself, see how you do. And you also have my math lab. It's really great to practice on your own and then see and check your answer, see if you got it right. See if you're understanding. So A is -4. So -4 goes in here. So we have -4 squared. Plus B times C. So that's +4 times -7. Minus B squared, and B is 4. So -4 squared. So the first things we need to do are the exponents. So -4 squared is 16. Plus 4 times -7. And then 4 squared here is 16. Next we do the multiplication. So 4 times -7 is -28. Supposed to do addition and subtraction from left to right. So if we had $16 and we spent $28, we have to subtract these. So that's -12 that we're still in debt. -12 minus 16 is what we have. So if we are in debt $12 and we spent $16 more, we're definitely in debt $28. That's one way to do that, the answer, get the answer there. So that's it. So for this week, just a reminder about what assignments are due, quiz and a test. And that's it for this week. I'll see you in class.